Hello everyone, I am Dallison. I'm glad to share you our work, which titled A Study of Dropout-Induced Modality Bias on Robustness to Missing Video Frames for Audio-Visual Speech Recognition. In this paper, we focus on a multimodal application called AVSR, which utilizes face video to enhance speech assist systems, especially in noisy environments. The face video provides additional speaker and semantic information that cannot be interfered with by acoustic noises. Hence, AVSR is considered one of the most promising solutions for the cocktail party problem. That is to recognize individual speech in a noisy, multi-speaker environment. Previous works on AVSR primarily focus on specific types of video, such as interviews or TV programs, which provide high-quality videos with a clear view. However, when it comes to open-world scenarios, current AVSR systems are observed to be highly sensitive to perturbations in the videos. One of the most common challenges is video frames missing problem. It could be easily caused by head movement, poor lighting, or network latency, and lead to significant performance degradation. More severely, it even makes AVSR perform worse than unimodal ASR systems. To address this out-of-distribution issue, data dropout on training video data is a simple and efficient method. It doesn't need extract consumption or complex modules. However, when faced to open-world scenarios with lower quality videos, we observe a contradictory phenomenon. As shown in the line chart, while the data dropout technique indeed improves missing robustness, it also causes performance degradation when processing complete data inputs. Here we first analyze the underlying reasons from the perspective of modality bias. Generally, multimodal applications can be categorized into two classes. The first one is modality-balanced systems, where each modality contributes relatively equally in the model decision process. Typical systems include multimodal emotion recognition and hate speech detection. The second class is modality-biased systems that over-rely on one certain modality. AVSR is a typical modality-biased system dominated by audio. Considering this point, an intuitive insight suggests that although data dropout on the video could reduce the domain gap between training and test, at the same time, it also exacerbates the modality bias on audio. This excessive modality bias on audio enhances missing robustness to video frames but degrades the ability to utilize video information. To verify this hypothesis, we conduct three quantitative similarity analyses, ranging from the macro CR score to the latent embeddings distance. We use ASR and standard AVSR training as references for modality bias. Comparing similarities with these references highlights the degree of a model's modality bias. In the first plot, we notice a transformation tendency in the CR degradation curve of AVSRs with different training dropout rate. As the training dropout rate increases, the curve of AVSR starts from red line gradually converges to ASR, the dashed line. This tendency is more evident in the second plot, where a higher training dropout rate leads to a lower relative CR with ASR, which means a greater similarity in transcription. Furthermore, as shown by the increasingly bright diagonal from left to right in the third plot, the similarity tendency can also be observed in latent distribution space with complete data input. These findings reveal that data dropout in supplementary modality exacerbates model bias and prompts the model to converge toward trivial solutions. Essentially, the perturbation in training data distribution leads to a shift in the model's latent distribution from a multimodal joint latent distribution to a unimodal marginal distribution. We refer to this phenomenon as dropout-induced modality bias. Although dropout-induced bias enhances missing robustness to video frames, it makes the model more sensitive to acoustic noises. We emphasize that this contradicts the primary design goal of AVSR as a robust speech recognizer in noisy environments. To achieve both performance and robustness, the key point is to prevent excessive modality bias caused by data dropouts. Here, we propose a novel multimodal distribution approximation framework using knowledge distillation, which called MDA-KD. Unlike traditional knowledge distillation methods in our framework, the difference between teacher and student models is modality bias, rather than size or architecture. Specifically, the teacher model trained on complete data pairs serves as a relatively unbiased anchor point. It is expected to constrain the distribution shift of the multimodal latent space towards an unimodal distribution during the student model's robustness fine-tuning stage. Additionally, when facing severely or entirely missing video frames, we consider it unreliable to continue employing a synergistic decision-making strategy like MDA-KD. In such scenarios, a dynamic switch in decision strategy is necessary. Considering the success of adapters LLM, we attempt to extend this approach to address the modality missing problem. Specifically, LoRa adapters are applied to audio branch. When activating adapters, we can easily shift the model's decision to be dominated by the audio. We highlight two advantages of this method. First, it makes full use of unpaired unimodal training data and unimodal data augmentation. Second, it's easy to modify the computation pathway to reduce computational costs. For experiments, we compare our system with other dropout methods and SOTA systems on the MISP2021 and MISP2022 challenge. We achieved 2 new SOTA performance in both segment-level and session-level recognition tasks. More details could be found in our paper. Finally, to summarize, in this work, we discover and analyze the essence of dropout-induced modality bias. Based on these findings, we propose a new multimodal distribution approximation using knowledge distillation. It maintained performance and robustness simultaneously. Furthermore, we apply adapters to handle videos with severe missing rate. Considering the generalization of this work, we intend to extend our findings to other modality-biased systems like autonomous driving sensor perception or audio-visual speech enhancement. Well, finally, thank you for your listening.